We're now up to the second part of analyzing Android applications. So we already did the first part here, and now we're going to talk about the Android security model, the beginning of it, which is very strange and, of course, very important to us, security being our main thing. So we'll talk about code signing, permissions, the sandbox, and encryption. So the basic security model is that every app should have its own memory space, and it should not be able to access another app's data, except if that's authorized, which is what you want. Every OS makes some effort to prevent this, but they have different techniques. And for Android to do this, they also have to know who created an app, so they can tell, for example, whether Google created it, because Google's apps get special permissions. And also, they want to know if it's the same developer when they come in later with an update, whether it's okay to update the app. But they also have the open source requirement, which Apple does not. Apple is quite happy to make a closed environment where they control everything. You have to go to their permission to put on an app and all that. Google is not willing to do that. They want to have an open source system, so you can write your own app, you can put it on your website, you can just distribute it to people, you don't have to go through Google Play, and it's intended to let you do that. Now that means there's a ton of malware, because they have no way to stop it. They can do something about the malware in the Google Play Store, although they're not very good at stopping it there either. But since you load things out that are not in the Google Play Store, they don't have any chance to stop the malware. So it's just a more open model. And that is intrinsically more dangerous. So code signing is, digital certificates are used to sign any code. I've got them, you get them, most Windows machines won't run unsigned code anymore. They'll complain a lot. And this is, so your code signature has the name of the person who bought the certificate, who has to prove that they're a legitimate business to some extent just to get a certificate. And then it has a hash value of the app and a encrypted a signature made with private and public key cryptography, so that it can verify that this app has not been modified. And nobody could modify it, because if they did, the signature wouldn't match. And then they could not calculate a replacement signature because they don't have the private key. So that's the game, and it's really very good. It's the same way you sign websites when you log into them with HTTPS, and it works fine. The problem is the digital certificates here are self-signed. They are not bought from a certificate authority and signed by someone else. So anybody can make a new certificate. So you can just generate the key with Key Tool, and you sign your app with Jar Signer. You can just do it here. So here's the Progressive app you'll use in the project. That's the real Progressive app from a couple of years back. The new one probably unpacks too. The app itself is in something called base.apk, which is a common name they use for them. A single APK file is a zip file containing all the pieces of an Android app. And to unpack it, you need an unpacker. An APK tool is an open source unpacker. And as you see, it unpacks the thing. It decodes the Android manifest, which is XML, which comes in some goofy binary format, and it reverses it all the way to readable plain text. And it loads the resource table, and it opens the classes.dex file that contain Java code, and it backsmalls them, turning them into Smalley, which is Java bytecode, which is very readable. So you'll see the certificate. If you go into the base original META-INF folder, you'll find the certificate. The certificate is a binary file, but you can open it with Key Tool, which comes with the Android tools that you installed. And so you can print out the certificate, and here it is. Here's the owner of this thing was Matt Lehman, Progressive Insurance. It was valid from this date until that date, 2009. Holy cow, they're not messing around. Usually you make these certificates good for 25 years, but Progressive, in their wisdom, has taken an optimistic position and made their certificate good for 1,000 years. Yeah, I kind of doubt Progressive will still be around signing this app's updates at that time. But anyway, it has a fingerprint. Yeah. Anyway, and it's got 1024-bit RSA key, which is quite weak. That's not recommended at all anymore. It's never been broken by brute force, but a 768-bit key has been broken. So 1024 is considered not safe enough. Now it is recommended to use 2048 or 3096 for security. But you must understand, you don't need a strong security for this kind of signature, because the concern of them forging them is there's more they'd have to do to successfully forge it. Anyway, it uses SHA-1 with RSA. It's using SHA-1, which is now a deprecated hash function, and RSA 1024, which is now a deprecated public key encryption. But for this purpose, those are probably fine. Forging it would really be quite difficult. So you can view the certificate with OpenSSL. There's kind of a long command that'll read that binary file and then print out the certificate. And now you see the certificate in the X509 format, which is a long format used for internet certificates. You have a serial number, you have an issuer. But here's the goofy part. The subject is Progressive Insurance, but it's issued by Progressive Insurance. If this was a HTTPS certificate on the web, you're not allowed to do that. Only a trusted root certificate can sign it, and there's 100 of them built into your browser, and if it's Google, it's issued by somebody else. But here it's self-signed, so there's nobody to verify that I'm really Progressive Insurance, so I could just call myself Progressive Insurance and make another certificate that would look just like this. There is nothing to prevent that. The only thing is I couldn't get the same key and the same values, so if I tried to make my own certificate and sign an update to this Progressive app, it wouldn't take it because the new signature doesn't match the old signature. What I could do, though, is make a fake app with a signature that looks like Progressive, and if you don't already have the app, and I'm the first one you put on, then you would have no way to know that's not true. That's the problem in not having a trusted third authority, trusted third party. And so this is the signature algorithm, and there's the actual certificate itself is this blob of base 64. All right. Now, there have been MD5 collisions. This happened in, I think, in 2008. VeriSign, a real certificate authority on the internet, made signatures that were still using MD5, not even SHA-1. And that was so bad, you could, in fact, make a forged certificate, and they did it at DEF CON. They made a forged certificate so they could pretend to be an HTTPS secure website with another name. And that was a black eye for VeriSign because they should have quit using MD5 long ago. Anyway, but no one's ever done it with SHA-1. Why is the signature good 24 years? That's just the recommendation. You could make it good for anything you want. The problem is if you made it good for only like 1 year, then after a year of updating your apps, you wouldn't be able to update the app anymore. You'd have to tell them to remove it and download a new app, and that would be a bad customer experience. So they just recommend, I think it's Google, just recommends 25 years as the standard time. Realistically, you just have to ask yourself, how long are my customers going to keep using this app? How long before they buy a new phone? Or, of course, they might move the app to a new phone. Make this estimate. How long do you think they're going to keep using this same app? All right, so there's a page on here to links that explains mathematically why these forging a certificate is much harder than finding a collision, because there is one known SHA-1 collision. Google found one about 3 years ago. They made 2 PDF files that hashed to the same SHA-1, and that's why everyone said you should quit using SHA-1 because it's not perfect. However, forging a certificate requires more than just one collision. It requires a chosen collision, which is much more difficult. So, all right, so Android doesn't verify it in any way. There's no certificate authority. It's self-signed. It only checks it when the app is installed, and all it does is record it. It doesn't really have anything to check it for validity. It just records it, so it'll notice if the same certificate comes in again. And as we'll see, it uses it to identify other apps that might be in the same family as the app, so you could share data between them if you want to do that. Book says that to make app. Yeah, that's right. All right. So, Google recommends 25 years or longer. All right. And so there turned out to be several serious signing vulnerabilities. The master key one is one found in 2013. If the APK is a zip archive, you can put 2 files with the same file name in the archive. And if you do, the validation process does not check that, where it verifies the signature. It only checks the first file's hash. So you can put a second file in there that is not compared to the certificate. So you could take the valid app and you could add another copy of a file, duplicate an existing file, and it would not detect that. And that app would in fact end up on the device, that extra file. This, by the way, is also true of Microsoft code signing. I heard it in the podcasts or in the Extra E1 project. There was a guy that did this. He found he could add extra text to the end of Microsoft signed code, and that also was discovered in 2012 and passed in 2012, but Microsoft did not turn the patch on by default, and almost nobody knows about it. You have to go into the registry and turn on optional keys to have this patch. So there's a similar flaw with Microsoft apps. Anyway, that's pretty bad. Oh, I think this is patched on Android. Then there's extra field length. There's a length field, which is a 16-bit value, but Java treats it as a signed instead of an unsigned integer. So if you use large values, they will be interpreted as negative values. And that means you can trick it into ignoring parts of altered files. Again, very similar to the previous one, you can now inject extra code that will not in fact be examined by the verifier. And there's a name field length, the same thing. The length is not checked by the verification code, so you can just add extra data in the file name and it won't check for that either. So there are various ways to sneak extra text, modify an app, and the signature will still come out okay. It's also true of Microsoft signatures. All right, so that's a flaw. Understanding permissions, this is the Android permission model. When you install an app, this thing will pop up and say, are you going to let it have access to this and this and this? Now, I think you might be able, the one nowadays, in the latest modern version of Android, you can actually line item veto some of these. So you could say, no, I don't want you going to my camera because I don't think you should. And that might do you some good. But most people just accept them all. And apps often get more permissions than they need to. And in fact, there are a variety of vulnerabilities where your app can actually access things it's not supposed to. This permission model has its flaws. Anyway, that goes into the Android manifest file, this XML file showing access course location is true, get accounts is true, and so on. It goes, various permissions, receive boot. There are various features that this app has. All right. It's the manifest for an app. So you can define permission protection levels. For example, here you've got a CD2 message. That's the name of their permission. You can define a new permission if you want to, and then you can define a protection level. This protection level is signature. So you can define this level of permissions that it has, and here's the types of levels. Normal is the default value, which is considered safe. Dangerous is a higher risk permission that would give it access to private user data or control over the device, not recommended. And signature is what's generally recommended for general use. This means that a permission that the system grants only if the requesting app is signed with the same certificate. And now this means that if you get permission to access the camera, then you give that a name, Skype reaching a camera, and the only thing that can possibly get that is the Skype app itself or another app signed by the same developer at the same certificate in case you wish to develop a suite of related apps and let them all have the same permission. And this came up a lot with Skype. Early versions of the Skype app defined a new handler called tell, and you could just make a link on a web page, tell, that would dial the telephone without popping up anything or telling you, and so you could make toll calls without telling people and get money from them. And they wanted to restrict that only to Skype. So that was what they did, was they changed the operating system on all phones so that every time it makes a phone call, it pops up a box to ask you to validate first. But anyway, then there's signature or system. This is another way to do it. So this only gets to applications that are intended to be from Google, essentially. They got to be in a dedicated folder on the Android system image or signed with the same certificate as the application that declared the permission. They don't recommend this signature or system. They say all you really need is signature, but I think their system, system is the ones from Google. Part of the Android system, they of course have high permissions, and anything you write cannot have this unless you work at Google. And then there's development, which is poorly documented, and it's not entirely clear what it does. So signature is what's recommended for apps that don't intend to share data or functionality with apps from other developers, but only say within the same suite of apps from the same developer. That's generally what you want to do. Malicious apps can just ask for a lot of permissions and hope the user doesn't pay attention and allows them, which is normally true, or they can use a kernel exploit to gain root. If you want to gain something beyond your allowed permissions, you have to have a kernel exploit to subvert the security model in the kernel, because you have to move from one user account to another, and this is what you have to do to escalate privileges on Linux. From user to root, you have to violate the kernel security model, and that requires a kernel flaw, and Linux systems have a kernel flaw about every 6 months. So if your phone is more than 6 months out of update, there's probably a known kernel flaw to escalate. All right. So the applications are in what's called a sandbox. A sandbox is just a term for some kind of container that limits what your app can do and how it can't leak over where other apps live. And the way it does it here, as I mentioned before, is every app has its own permission. So here's Coinbase is A145 and Schwab is A129. Every time you install an app, it creates a new user account and assigns that app to that user account and creates their data folder owned by that user account. So they separate you the way Linux would separate different people. And so unless you run your app as shared user ID and has the same signature as another app, then you won't be able to run it as anything else. Now here, you notice the Schwab mobile app actually has XXX. It has execute permission for everyone, so everyone can run it, even from other accounts, which is interesting, and I wonder what they're thinking there. Maybe they're thinking you could have some other company's financial app and you'd have a button to open this in the Schwab app or something. I don't know quite what they wanted to do there, but they're offering some functionality to the world, all the apps on your phone. But most apps don't do that. So here's the limitations. You do not have a separate virtual machine for each app. They're sharing the same system folders and same, so all you have is Linux user and group permissions, so they're not that isolated, but there is some isolation. And then there's encryption. This is a big weakness of Android. iPhones, ever since I think the 3S, have been encrypted the way they should be. By default, all the data is encrypted before you even get the phone. So before you ever use it, when you first set it up, everything's encrypted. Everything encrypted all the time you use it. So if you want to sell your phone, you just go to the settings and reset to factory defaults, and all that does is erase the key. And all the personal data is lost beyond redemption. And several years ago, a forensic firm wanted to test this, and they bought 100 used iPhones off eBay, and they were unable to get any data off any of them. It really, really works, and that's the way to do it. You have to have encryption turned on before you ever touch it, always on, and then you delete the key. That will do it. Android does not have that because they want to save battery life, and there's another thing about this. Apple, in addition to being very rigid about their apps, they're very rigid about the power consumption of apps. You can't get in the store without meeting the requirements, and the requirements are relatively strict. Android is not, emphatically not. I got to go to Google I/O a few years ago, and I went to a lot of talks where they talked about how we're tired of apps draining the battery. A lot of people write these crappy apps and drain the battery, and they said, here's what you have to do, and it was very complicated. Not easy at all. Run this thing, download this thing, check this thing, do this complicated stuff. I can see why people don't do it. There were a ton of apps that just run something all the time at full blast, draining your battery. So there's a battery problem in Android, and most of them don't have encryption on by default, although the latest, best hardware, like from Google, does have encryption now by default. But most Android phones are not encrypted by default. And that's a problem. The only thing that protects you from a stolen device is if the entire disk is encrypted before you ever start putting data on it. If you use it for a while and then put on encryption, it is less effective because some of the data you put on there was not encrypted, and when you turn it on, it is not re-encrypted later. And when you make data on a drive, copies of that data are put all over the place in temporary files and in sectors that are bad. You can never really be sure that encryption applied later really reaches it all. That's why you have to have the encryption on before you start using it if you want to have high security, high belief, high confidence that all the data is encrypted. Anyway, that's the game. They're supposedly coming up with something else called 5-bile-based encryption instead of their current full disk encryption. And I don't know much about that, but it should be out by now. Anyway, there's another enormous problem with Android. Is that people buy the phones, and the carrier usually only gives you updates for about 2 years, and they do not have, or at least, I don't know if they finally have it now, at least as of a couple of years ago, they did not have a security update channel. It was all or nothing. And therefore, the updates from Google would typically include both security updates and new features, but the carriers were often charging you money for that feature. So they didn't want you to get the free update, which would add that feature, so they blocked the update. So a lot of phones refused to deliver the updates from Google, and so many, many phones in use are 2 years or more behind on their updates. And they're running really old versions, as you can see, versions all over the place. Here, at least this goes up to 2020, but you can see here's really old version. All these different versions are in use. Most phones are not running the latest version, or even the version behind that, or even the version behind that, which is the kiss of death because there's known exploits that come out all the time. If you don't update, then there's just a known tool you can download to hack into your phone. So that's why there's so much malware on Android. It's a very unsanitary, very dangerous system. Now, of course, if you're a sophisticated user, you could root it and put in your custom ROM and take over controlling the OS yourself and then put on the updates and keep it up to date, and that would be fine. If you're taking the responsibility of securing your phone, and if you know what you're doing, you can do it. But the average user that just buys it and does whatever the default thing is at a lot more risk than they would like, and that's why you really need to run antivirus on your Android phone, just like your Windows machine, because the intrinsic operating system is not very secure at all. Anyway, so here's limitations. It doesn't encrypt the SD card. It only protects data at rest. So if I can get you to put malware on your device, which is just as easy as saying, click on this link and install this fun game or wallpaper or something, then I can read the data in RAM and in principle, find your secrets, although I may need a kernel exploit to reach into some other area. What anti-malware do I recommend? Well, I don't know. There are a bunch of them. Blue Box was the first one, but now I think there's dozens. Android. I know there were at least 10 last time I looked. Yeah, well, here's a recommendation. Let's see. Tom's Guide is probably better than nothing. Blue Box was one of the original ones, and there's like McAfee and Avast and Norton and all that jazz. So what do they like? They like Bitdefender. Yeah, I think I've seen Bitdefender score pretty highly. Norton's famous. Avast. Kaspersky is very good, although the problem is they're Russian, and therefore it's not recommended for Americans involved in the government to use them, although they're usually technically the most expert. They have the best virus definitions. I mean, they do the technical part best, but right now...
Yeah, I remember I saw a test.
Yeah.
The top 2 antiviruses, it was Kaspersky and Bitdefender, and they were pretty much identical.
Yeah, but you know, there was a test about 5 years ago. Kaspersky got fed up with this, so they deliberately detected a dozen fake viruses, and within a week, all the other ones were detecting them. They're all just stealing their definitions from Kaspersky. Kaspersky is doing all the work. And that they had the most intelligent analysts really finding the viruses, and they were very, very, very upset when the U.S. government deprecated them, but they were used to steal our SolarWinds tools. The Russian military did use Kaspersky to steal our tools from us, so, you know, that's why I don't recommend using a Chinese antivirus either, for the same reason. You really don't want to give Russia or China root on your phone if you're in America, especially if you're involved in the government or the military. But anyway, it's technically a very good product, but there's a political problem. Anyway, then there's Lookout and so on. I don't see Blue Box anymore. Blue Box used to be one of the contenders. But anyway, all right. The antivirus software cannot gain the same level of privilege as Android and iOS. Yeah, there is no antivirus for iOS. Oh, you asked about iOS. I didn't see it. There's no antivirus available for iOS. You can't get it, and you don't need it. You have different levels. You can't turn on a firewall either. You can't do any of that because you only get stuff from the store. Now, if you jailbreak it, then you can get it infected, and then you can put on a firewall and stuff, and probably ClamAV or something. But in iOS, you just avoid the whole issue by not being able to put on so many apps. So that's why for an ordinary customer who's not very sophisticated, iOS is a much better choice. Because if you just click on things and don't know what you're doing very much, you're fine on iOS. Apple protects you, and they also limit you. You can only put on official stuff from the store, and you have to pay for the games and everything. If you're willing to put up with that, you're very unlikely to get infected with anything. However, you cannot say the same of Android, not at all. It comes with freedom, and that freedom puts you at risk. Anyway, I think that's it for the slides. Yeah, so let's try Kahoot.
And what about macOS? macOS has an antivirus called Xprotect. And
it has what?
On top of that, I installed Bitdefender just in case, but what do you recommend?
Yeah, I don't really know. I put something on mine, but I didn't used to use any at all, but I started using stuff because I'm worried about ransomware. There is ransomware that will infect your Mac, and that will affect everything you can get to, and I have my cloud services connected. So I don't know. I don't know what the best one is. I went to the same kind of thing. I went to recommendation, and I found one that was sort of high rated, but I don't really know enough to be sure if it's good. But I would run it on a Mac now. Now, if you have a Mac exactly in its default settings, it won't install anything except stuff that's known good. But almost everybody turns that off. And if you do, then you're more at risk, and I did too, because you want to run free stuff, and therefore you should probably have antivirus. The risk is much smaller than on Windows or Android. I was just thinking, what would happen if I got ransomware? And the fact is, I would be hosed just like everybody else. I don't really have good backups of everything, and I said, you know, I should probably at least run antivirus on my Mac. Yeah, you met AV on Max. AV on Max is the same thing. I just go to a review site. I don't have any particular insight. Anything that's rated, you know, high by a standard review site is probably okay. None of it's perfect, you know. But you can have some protection. CNET 12. subscription. Well, yeah, I found that's right, I found one to pay for. They said it was pretty good for technical users. Got it on this Mac, although I didn't pay for it yet, so it's not, it's somewhere, this thing. Clam XAV. I got Clam XAV. I got to pay for my subscription though. It's not updated, but it was fairly cheap, and it runs on the M1. It's the only one I could find that runs on the M1. That's why I got it. And they said it was good, but a little hard to use, more for technical users. And I said, well, that's probably okay. That's what, when I looked, it was the only one that did. And so, yeah, Clam XAV. That's the one I got. Although I don't have any way to test it and see how good it is. Really, I'm just going by reviews. Yeah, I've seen. Yeah, I've heard of them. I didn't look for them though. Yeah, it's true. That'd be another way to go. All right. Maybe we got everybody. A Clam XAV. The code. It's up here. 481-3357. Good. Yeah. Maybe, are you at Kahoot.it or Kahoot.com? There it is. It's up here on the screen. Make sure you got the URL right, Kahoot.it. Yeah, sure. It's no fun if you can't get in. And we're at the right place. 481. There's a problem with the game pin. 481-3357. Oh, well, that's rude.
Try to refresh.
Yeah. Oh, your internet went down. That's what happened. That's what I figured. It's Kitty College thing seems to kick you off every hour or so just to drive you nuts. It happens to me in my lecture too. It admits you to recheck the box approving their stupid terms and conditions. I'll wait for you to get on. Yeah, sure. There's no hurry. We got the time. And delightful music. You could even have different music. Here we go. There used to be, oh, you know where it is? I couldn't find it. Here's themes. Oh, there we are. All right, there you go. Okay, good. Did you get in? Okay, all right. Well, then. Okay, that'll work. Yeah, you have to like turn it off and turn it on again and stuff. The phone is a good option. All right. Let's see what happens here. All right, so what does a signature prove? That's right, proves none of that. HTTPS proves all that. Android signatures prove none of that. They provide a lot less value than HTTPS certificates. All right, which vulnerability used two files with the same file name? Yep, that's the master key vulnerability. All right, so what file lists the permissions an app requires? Android manifest, that's where they are. Each app has a file like that listing its permissions. And some other configuration settings. All right, what permission level should you use for a new app? Signature is what's recommended. Then you know nobody can use it except your company. All right. Let me stop this recording, if I can find it.